We are going to look at the packet that's titled Trig Functions in the Coordinate Plane. Remember, this packet can be found in Google Classroom, so make sure that you have it sitting in front of you prior to taking these notes. And you can pause at any point in time if you need to catch up on the notes or to put some side notes or anything else that you may need to do. All right, so the objective is, given a point, determine the trig functions of the right triangle. So what you're going to see on the second slide is based off of which quadrant you are working in. Remember, quadrant 1 is this top right, and then it moves counterclockwise. So quadrant 2, quadrant 3, quadrant 4. So based off the quadrant that you're working in, only certain trig functions are going to be positive, which means the rest of them are going to be negative. If you're working in the first quadrant, all trig functions are going to be positive in the first quadrant because you're moving to the right, which is positive, and up, which is positive. In the second quadrant, only sine and its reciprocal cosecant are going to be positive. All the other trig functions are going to be negative, and that's because we're working with a point that we would have to go to the left, which is negative, up, which is positive. Quadrant 3, only tangent and its reciprocal cotangent are positive. The rest of the trig functions in this particular quadrant are going to be negative. And finally, in quadrant 4, only cosine and its reciprocal secant are positive. The rest of the trig functions are going to be negative if the point in the right triangle sit in the fourth quadrant. Just some ways that they could write this when you're working with a problem. For instance, if they were to say that the cosine of theta is greater than 0. Greater than 0 means that it's a positive number. So if we look back over here, which quadrants would cosine be positive? Where it could be in quadrant 1 or it could be in quadrant 4. If they then said that the tangent of theta is less than 0, so right now we have the cosine is greater than 0, so it's either quadrant 1 or quadrant 4. Then we've got the statement tangent of theta is less than 0, which means that it's negative. Well, of these remaining two quadrants, the only one where tangent is negative would be right here in quadrant 4. So that means you're working with quadrant 4. If it gave the statement that the tangent was greater than 0, that means that tangent's positive. Well, tangent's not positive here in quadrant 4, so that means we would be working with quadrant 1. So in your assignment, when you see statements like this, it's trying to give you hints about which quadrant you are working in. So you want to eliminate the quadrants, two of the quadrants given the first statement, and then the second statement will tell you which of those two quadrants would be your actual location. An easy way to remember which quadrants have which trig functions positive will be on the next slide, where it says all students take calculus. All trig functions are positive here. Sine, student starts with S. Sine and its reciprocal cosecant are positive. T for take, tangent and its reciprocal cotangent are positive. And C for cosine and its reciprocal of secant. So all students take calculus is just one way to help you remember which trig functions are positive given which quadrant the right triangle is sitting in. So the next slide that you see in your notes is the set of directions that we are going to be using to complete the two example problems. So they're going to give you a point, you're going to plot that point, and then you're going to connect that point to the origin, and then also connect that point to the x-axis. What this does is it creates a right triangle. Then we will put theta, or label theta, at the angle that is sitting at the origin. And then we're going to label the opposite and adjacent sides appropriately based off that location of theta. Find the hypotenuse using the Pythagorean Theorem, and then be able to find any of the 6 trig functions that you are being asked for in the assignment. We don't necessarily have to find all of them on the examples that we're going to look at, even though it says so. But just know for your assignment, you're at least going to have to be able to find one of them. So let's look at the first example. It says find the 6 trig functions using the point -5, 6. So if I plot the point -5, 6, I have to go 5 to the left and 6 up. So there's my point -5, 6. So I'm going to connect that point to the origin. And I'm going to connect that point to the x-axis. And that creates my right triangle. I'm going to put theta where the origin is at. And then I'm going to start labeling my sides. Well, this side I had to travel -5. This side here I had to travel a +6. So I'm going to use the Pythagorean Theorem to help me find the hypotenuse. So remember, the Pythagorean Theorem is a squared plus b squared equals c squared. A is -5. B is 6. So I have 25 plus 36, which is 61. And to get c, I've got a square root. The square root of 61 does not simplify, so that is the length of the hypotenuse. So now I can find any of the 6 trig functions. So let's say I wanted to find cosine of theta. Cosine, remember, is adjacent over hypotenuse. So based off my picture, if this is my angle, then this is my adjacent side, and that's my hypotenuse. So I have -5 over the square root of 61. But remember, you can't leave a radical in the bottom. So I'm going to multiply top and bottom by the square root of 61. So the cosine of theta equals -5 square root of 61 over 61. If they wanted me to find, let's say, cotangent of theta. Cotangent is the reciprocal of tangent. So cotangent is found by taking the adjacent over the opposite. So adjacent is -5, opposite is 6. So the cotangent of theta is -5/6. On your assignment, they're not going to ask you for all 6. They're only going to ask you for 1. So just make sure you know how to find at least one of the trig functions based off the point that is given to you. Let's look at the second example. This time we're given the point 8, -2. So I'm going to start at the origin. I'm going to travel 8 to the right and down 2. So there's my point. I'm going to connect that point to the origin. I'm going to connect it to the x-axis. And there's my right triangle. Theta, again, is always located at the angle that's sitting with the origin. I had to travel a +8 for this side of the triangle, and I had to travel a -2 for that side of the triangle. So now using the Pythagorean Theorem, I have 8 squared plus -2 squared equals c squared. So I have 64 plus 4 equals c squared. So now I have 68 equals c squared. If I square root that, I get the square root of 68. Can we simplify the square root of 68? So we've got to think of the numbers that we know the square root of. And it just so happens that we can split 68 into 4 times 17. And the square root of 4 is 2. So 2 square root of 17 is the value of c. So now that I know all 3 sides, I can find any trig function. So let's say for this trig function, I wanted you to find, let's say, cosecant of theta. Remember, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. So here's theta. Hypotenuse is 2 square roots of 17. Opposite is -2. So I have 2 square root of 17 over -2. 2 over -2 can be simplified. So I have negative square root of 17 for my final answer. One more, let's say I wanted to find tangent of theta. Tangent is opposite over adjacent. So opposite is -2, adjacent is 8. So I have -2 over 8, which simplifies to -1/4. Your answers for these should never be a decimal. They should always be a simplified fraction. Hopefully you are able to understand these notes okay. Don't forget to join me on Tuesday at 10 o'clock if you have any additional questions.